Greetings and welcome, friends. Mr. Waddy and my fellow geometricians are here. We're talking today about relationships between angles when you've got lines that are parallel, but then another line that's definitely not parallel to the other two that I mentioned already, but it intersects them. We called that line a transversal. And this is some of the things that are true about special angles in those situations. So if I've got two, ooh, that's a crazy arrow there, two parallel lines cut by a transversal, the claim is this. Hey, oh, guys, this is a theorem. That means it's supposed to be proven, although I've already told my geometrician friends in real life, not my internet friends, that this was a postulate back in my day. It was accepted as true without proof. But it is a theorem, so we're going to prove it. And notice it's a conditional statement. It says if two parallel lines are cut by a transversal, all right, that has been completed. Hypothesis has been met, right? Therefore, then the pairs of corresponding angles are congruent. So they're claiming that this angle and this angle will be congruent. Now, you don't have the tools geometrically to prove that right now. That's something we'll talk about in chapter 4. But watch this. This is going to be my fake proof for you guys. Ready? It's a proof based on transformations, specifically rigid transformations. I'll define that for you in chapter 4, which says that an object that experiences a rigid transformation, that its image will be congruent to its pre-image. All right? Imagine this. If I move an object, it's congruent to itself from where it originally was. So that would be things like translations, reflections, and rotations. And so if I copy one of these angles and then translate them, it's still congruent to its original self. And notice this, if I translate it along the transversal, if I drew those lines truly parallel originally, you'll see that it maps 1-to-1 on top of the other corresponding angle. Therefore, they're congruent, is their argument. So there's your basic layman's proof of the corresponding angles theorem, affectionately referred to as CAT, or from my day, I might still refer to it as CAP, back when I used to know it as a postulate. And it turns out that's true, that corresponding angles are congruent. And not only those two, but also these two, and then by like vertical angles and all sorts of things. It turns out, whoa, not that one. It turns out we'll only have two types of angle measurements in all four of those angles at those two intersections. So it's kind of a nice little setup. Similarly, once I know this is true, these other theorems will be more easily proven, okay? So alternate interior angles theorem, Yep, that's how you can pronounce that. You're doing the math on the street. It says if two parallel lines, oh, I think I've heard this before. Two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So here and here, those are congruent to each other, and here, those are congruent to each other. Yeah, it says there will actually be a proof, example 4. That sounds like something we might be doing today. All right, here we go. And those aren't the only ones, friends. We have some more theorems coming at you. It's going to be amazing. And here we go, here we go. Can I line up the screenshot? Right, tensions are mounting. I think that was a miss. It was a miss. Ah, man. Like you guys are gonna share this video on social media later to all of your perfectionist friends just to annoy them. They'll be like, "Oh, it's barely off by a pixel," but that's okay. So let's see. Alternate exterior angles theorem. Eight. All right. And guys, by the way, the fact that these are theorems means that once they're proven, you'll be able to reference them in other proofs of other things. That's great. So if two parallel lines cut by a transversal, parallel, transversal, then then the following is true. The pairs of alternate exterior angles are congruent. So like there and there and there and there. Lovely. And then good old Kayat, consecutive interior angles theorem. This one's the one that's a little bit of an oddball compared to the rest. Two parallel lines cut by a transversal. Also, if I don't know these are parallel, then do I know the conclusion? No. This is only true, to our knowledge, if they're parallel and cut by a transversal, okay? So two parallel lines cut by a transversal. I don't have a great way of labeling this, but these angles add up to 180. All right, if I call that angle 1, angle 2, I could say measure angle 1 plus measure angle 2 equals 180. All right? Yeah. So those are kind of like all of the relationships you need to worry about. And now it's just a matter of applying these theorems. And we'll then maybe even do some proofs with them later. It's going to be great. Here's example 1. The measures of 3 of the numbered angles are 120 degrees. Identify them. Here we go. Okay. Someone want to help me out? Some guests on the Wadi Math channel. If you give me an answer for one of these, maybe I'll even promote your own YouTube channel. Maybe. No, I'm getting no. They're not internet friends. I don't think they're fans of that idea. That's all right. All the views from me. But nonetheless, what's an angle that's also going to be 120 degrees? Yeah, Sarah. Angle 4. All right. So angle 4 is congruent to angle. I'll call this 1. Why are those two congruent? Yep, vertical angles theorem. And then their measures are equal by def of Kong. They weren't looking for all of this explanation. But I'll do it once for us. Def of Kong. And then by substitution, I could plug in 120 for measure of angle 1. And I'd say measure of angle 4 is equal to 120 degrees. The big argument here is vertical angles theorem. Question, comment, observation? Or another answer? Okay, so this last answer was provided for you by Sarah Math on YouTube. No? I don't know. Maybe that's a channel. Maybe it isn't. Maybe I'll go register it right now. Look out. I'll pretend to be someone else doing math. That'll be great. Abe, what are your thoughts? Yeah, I guess I'll say it proper. Angle 5 is congruent to angle 1. That's a sad congruent symbol. Why is that true? It's a theorem. Unless you're old school. But yeah, those two are corresponding angles. That's one way we could do it. What's another way I could have justified that based on the information that I've already concluded? Nolan? Yeah, alternate interior angles theorem. Now that I've known angle 4 and then some sort of transitivity between those, right? So that's also something. And then I could say, right, angle 5, the measure of, is also 120. What's another one? Un otro. Yeah, Nick. Angle 8 is congruent to angle 1. Why is that? 8. There we go. Alternate exterior angles theorem. Those two are, in fact, congruent with each other. I also could do a train of transitivity, right? This is vertical angles with that. It's corresponding with 4. All sorts of different ways we could say that. That's it. Yeah. Good. Let's keep going. Here we go. Now they're doing the classic of mixing in some algebra with our geometria. Find the value of x. Okay. Now there might be multiple approaches here. Let's see. You guys just laid eyes on this problem. Thoughts? Alex, do you have thoughts on this? All right. So you're saying that that angle and this angle should add up to 180. What was your like middle step logic that would have justified? I agree, but how would you have gotten to that? Okay. And that is allowed. You could have just called this like, I don't know, angle 12 or something like that, and referred to with corresponding angle, and then you know those are a linear pair. Yep, so that's one jump. I think the jump they were setting us up for, but not that you had to use it, was that it's congruent to this. And why are those two congruent? Vertical angles theorem, and then angle 4 and this angle are consecutive interior. And then, yeah, there'd be some substitution. There'd be some things like that. But yes, I agree that x plus 5 plus 115 is going to equal 180. Hey, I was just teaching my algebra buddies how to combine like terms and solve multi-step equations today. That's great. So let's see, x plus 120 equals 180. Combine like terms, right? Subtract 120 from both sides. And it looks like x is equal to 60 of the degrees variety. There you go, right? So multiple ways you could have gotten there. They weren't necessarily looking for explanations, but you guys knew. You guys knew the whole time. All right, let's look at example 3, another one similar. And I think the proof is coming up, example 4. All right, what's the setup here? What's a logical progression that might help me? Yeah, Nolan. Okay, so measure angle 1 is equal to 7x plus 9. So that's a def of Kong substitution statement after I knew that these two angles were congruent. Why were they congruent? Yeah, alternate exterior angles theorem would tell me that those two were congruent. How am I going to get to this 136 somehow? Yep, 1 and 136 are a linear pair. Actually, congruent supplements theorem? If 1 is supplementary with 136, then 7x plus 9 will also be supplementary with 136 because they were congruent or equal measure to each other. All right, so 7x plus 9 plus 136 is equal to 180, and then a little bit of algebra. That 135? Nope. 35, and x is equal to 5. And they just wanted the value of x, so we're good enough with that. Be always vigilant as to whether or not they're asking you anything here. So here's a proof, the moment we've been waiting for, because we don't even know if any of the other problems I've done are true yet, right? Like, so far, we've just been in pretend land. Yeah. Let's see. Prove that two lines that are parallel cut by... Oop, I just undooded that. There we go. It's back. I undid my undoed. Parallel lines cut by a transversal, that then the pairs of alternate interior angles are congruent. So they've given us a sketch, given information. Let's set up a 2-column. See. That's... I don't want my 2-column heading to just become that line. That wouldn't be helpful. So here we go. So statements, reasons. All right. I'm going to say P is parallel to Q. Why is that true? Given. Okay. You could also say T is a transversal, but it doesn't matter. What they've pre-labeled some angles for us. And when doing a proof that's this generic, you could label all of these angles if you want. All right, like you can name these things whatever you'd like. But they pre-labeled these, and I think they did for a reason. Now, I'm trying to prove that alternate interior angles are congruent. So my final statement should look Something like what? Yeah, Abe? Yeah. Yeah, it's my final statement's going to look like that, I'm guessing, because those are the only two that I'm looking for. I just wanted to point that out so that way we at least knew what we were aiming for. So how could I get there? Someone tell me. The only other theorem from today that you can use is the one that I've quote-unquote proven for you. I haven't proven the last three. Here. No. I proved this one-ish for you. And back in my day, it was the postulate, so that would have been the starting point for the others. All right, angle 1 congruent to angle 3, corresponding angles theorem. I can even label that in my sketch. Not a bad idea. Okay. Nolan? Cat vat. Oh, I'll have to tell you guys a story about cats and vats later. A vat? It's like a tub or a bin. Yeah, it'll be an interesting interesting story. So cat vat. Now what can I say? Yeah? Transitive property of congruence, technically. But if you just say trans prop, I'm fine with that. And what would that allow me to say? And that was, I think, what I set out to prove. So I think I'm good. All right. Very good. So yeah, so there's a proof. Ooh, here we go. We got example 5. Guys, this is like a pretty rainbow. On yours, it's just black and white or grayscale. Ooh, solving a real life problem. I don't know, if looking at rainbows is a problem, I don't think anything's gonna cheer this guy up. When sunlight enters a drop of different, let's see, a drop of rain, different colors of light leave the drop at different angles. The process is what makes a rainbow. For violet light, the measure of angle 2 is 40 degrees. What is the measure of angle 1? How do you know? All right, I'm being told measure of angle 1 is equal to 40 degrees by the alternate interior angles theorem, and technically plus some like def of Kong and substitution of there in there. But the big heavy hitter is alternate interior angles theorem there. But yeah. Cool. All right, so now you guys know all sorts of wonderful things about lines and angles. Hooray! Thanks for watching, internet friends. Bye-bye.